Hello, my name is Srideep Reddy. I am a student of Microelectronics and VLSI. So, today, actually, I'm going to perform the Wisconsin's breast cancer diagnosis using the K nearest neighbors, as you know. So, I will explain the code I have done it in the Google Colab platform. So, I will explain the code now. So, I hope you are able to see my code here. So, first of all, as we all know, there are some very vast libraries in the Python. As we know, the most famous are Pandas, NumPy, sklearn, Matplotlib, and these are the various libraries. And in these libraries, there are some parts which we get to use while using the algorithm. So here, as we know that we are using the Pandas, we are using NumPys, and then sklearn, it's a very vast library. So for the model selection part, we are importing the train test split. Like we are going to train some data, we are going to test it on some part of the data. So that on the entire data, in some part is used for training and other part is used for testing. In the same way, we have exported the nearest neighbors classifier also, and also accuracy score, confusion matrix, and these are also part of the sklearn. So these are the things. So now what we are going to do. So I have downloaded the data of the breast cancer from Kaggle. So this is the data. So as we know that we can use the read underscore CSV function of the pandas, and I have loaded the data. So here here you can see clearly, like we are dropping the unnecessary columns, like if there are any unnamed columns or unnamed rows. So to maintain the good accuracy, we are dropping the unnecessary columns. So as we also know, there is another NumPy method. We are going to use that. So we have used this also. Next. So we know if there is cancer, it is malignant, and if it is there is no cancer, it is benign. So what we are going to do is data. Here it is diagnosis. Data diagnosis dot map. So actually we are using. So simply, if we can say that in while loading data, if we want to target the exact data, like in this case, what we are actually doing is, like, to target the exact data, we are using data of diagnosis. Like the diagnosis part we are using, and actually we are targeting that part because of the fact that we don't want all features of the data. We just want the diagnosis part. So now let us do one thing. Let us split the features and labels. So here, as you know, we are using X for diagnosis. We are dropping the diagnosis data dot drop. That entire column we are dropping, and why we are using the diagnosis part, right? Now we know that we are going to train and we are going to test the data. We are going to divide it into two parts, and also we are going to make use of the algorithm, and we are going to predict the accuracy as well. The if if new data is given to the algorithm, machine learning algorithm, so it has to predict whether that person has cancer or not. So as we know, so now we are using this train test split. Here we know the testing size is zero point 0.2, as you can see here, and the random state 42, that's a random number. Next, feature scaling. So we are scaling the data actually, and And next, as we know, like we are fitting the training data, the both which we are going to train, we are fitting it in the KNN model as we can see over here. So the next after we have given the data to the KNN model, it has been trained. So it is a train model now. It's just like I can say it's just like a kid learning kung fu. It has been well trained now. So now what? So to assess that model, we have to use some data and we have to predict that. So as we know, we can predict on test set. So prediction is on knn.predict. It is also an inbuilt function. So okay, now we have predicted. So what it's this is just an evaluation. Like we can give marks, right? Or in case of a kung fu example, like we can also give black belt, yellow belt. These all are belts. If that the accuracy of the model is one, then we can obviously say that the accuracy is lot. Like it's ideal. The model is ideal. So in this case also we can see that here we can also see one second. So we can also see this diagnosis, like what the testing part of the model. So this is one advantage of the Google Colab. So that's why I've used it. And yeah, this is the evaluation of the model. We have predicted the accuracy also. So now the thing is, we have to predict for the new patient. Our problem statement is itself, we have to predict for the new patient. So let us give one example. Like we will give a new patient, like the testing part, we will give one patient from the testing data itself, so we can predict that. So if that prediction comes out to be one, like what it's meant by one, we already have defined above itself that if it is one, he has cancer is detected. If he don't have cancer, then we will print it as no cancer. So as simple as that, right? So let's see what's the result after running the data. So let us run now. So let us see this model evaluation. So here this part you can see, right? Accuracy is 0.94. It is okay. Like it's better model. It's not a bad or very good model, but you can say it's better. So we also have the confusion matrix here. You can check out here. And now classification report. So we can use this classification report. What's the precision? What's the F1 score? What's the support? What's the accuracy? And also what's the macro average? What's the weighted average? For everything, we have inbuilt model. Like in the KNN itself, we are going to use all this, and we are using this weighted average. And also, as we know that in the testing data, whichever the patient data we gave, it has predicted he has no cancer. So yeah, this is the model. So and also this is quite helpful because these days many females are getting affected to the breast cancer. Many data show that more than 12% to 13% increase in this. So machine learning model like KNN classification can help doctors and medical organizations to detect whether a person has breast cancer or not. So it's a quite helpful thing. I hope uh, this model is quite helpful in predicting the breast cancer. And thank you so much for actually giving